Luis Alvarez was born in San Francisco in 1911 and earned his Ph.D. at the University of Chicago, returning us again to our Windy City motif. After working for Ernest Lawrence in the radiation laboratory at the University of California, Berkeley, Alvarez joined the Manhattan Project and helped create the first atomic bombs. He was especially instrumental in developing the weapon's detonators, the high explosives, and the lensing system that focused the blast of conventional explosives inward so that it evenly compressed a 15-pound ball of plutonium from all directions simultaneously, turning it instantly supercritical simply by shrinking that soft metal sphere from the width of a softball to that of a tennis ball. He got to witness the results firsthand, as he was present at the initial Trinity A-bomb test in 1945 and was an observer on one of the 3 planes that took part in the Hiroshima bombing. A decade or so earlier, he was one of the discoverers of the strange east-west effect, the finding that cosmic rays arriving from deep space have preferred directions of approaching our planet, thanks to the interplay of their electrical charges and Earth's magnetic field. Since cosmic rays are created by violent events such as supernovas, it is clear that Dr. Alvarez was already intimately involved with the consequences of cataclysmic occurrences when he helped create some more, in the form of atomic weapons. This is the background against which he and his son, the geologist Walter Alvarez, made the discovery for which they will forever be best known. After winning the Nobel Prize in Physics in 1968, Alvarez focused on the strange, sudden extinction of the dinosaurs. Researchers had already suggested in 1953 that perhaps a cataclysmic impact event, a comet or asteroid smashing into Earth, was responsible for the radical change on Earth at the end of the Cretaceous period. But this remained merely an intriguing idea until Walter and Luis devoted over a year to uncovering inarguable evidence of the event. Back in 1980, when the Alvarez paper was published, the concept of mass extinctions seemed more like sci-fi or pop science. It was novel and controversial. Having laboriously moved away from Earth's biblical-type sudden occurrence scenarios that had dominated human thought for over 2,000 years, researchers were quite happy to visualize global changes as being languid events that unfolded over millions of years. They had numerous areas of solid evidence to support such lethargy. Climate gradually altered as tectonic plates collided and new mountain ranges arose, each of which influenced weather patterns, upper winds, sea levels, carbon dioxide concentrations, and hundreds of other interrelated factors whose relations were complex even for the latest ENIAC punch-card computers tackling them. Serbian theorist Milutin Milankovic showed that Earth's regional receipt of sunlight varied over separate cycles of 23,000 years, due to changes in how the Earth wobbles on its axis, 41,000 years, thanks to changes in its axial tilt, and 100,000 years, due to alterations in the shape of its orbit around the Sun. So clear episodic mechanisms for ice ages and other gradual planetary alterations were firmly in place. Obviously, earthly life would be affected by these. Probably some ice age had finished off the dinosaurs. But there was a problem, and it strongly suggested a bizarre, abrupt event of unimaginable violence. The fossil record showed that all the dinosaurs everywhere had died suddenly. They weren't just peacefully dropping dead from high cholesterol. One moment they were all over the planet after having lived and evolved for tens of millions of years, and then, in a matter of a few years, they were gone. Poof. Luis's son Walter was an obsessive geologist. He knew that the disappearance of the dinosaurs and many other simultaneous changes in Earth's biosphere had happened at a geological time marked by an abrupt alteration that could be dramatically seen in the Earth. It was a layer, a remarkable boundary, at which the color of the rocks and Earth suddenly changed from dark to light. You could view it in countless cliffs and highway cuts that were obvious from roadside rest stops.